All right, we are in Unit 2. We are in our last chapter here with doing our like little mini summaries of these notes, and this is Chapter 10. And in Chapter 10, our focus is just on like how to re-express data mainly. And again, we did the overview of the whole thing. I'm just trying to hit on little elements and key ideas along the way in each chapter. Okay? So, let's just get straight to the point here. We cannot use a linear model unless the relationship between the two variables is linear. Period. And often re-expression can save the day, straightening bent relationships so that we can fit and use a simple linear model, right? So there's a way for us to make it linear. Let's just do it. And two simple ways to re-express data, as we talked about before, are putting logs into them and using reciprocals. You can square them, you can do other stuff, but these are the first two that come to mind. Oftentimes logging them, or square rooting them, or reciprocals to the data to make it straight. Re-expression can be seen in everyday life. Everybody does it. All right, point is the relationship between fuel efficiency in miles per gallon and weight in pounds for late model cars looks fairly linear at first, right? Looks fairly linear. It might have a little bit of a bend as the car goes and gets heavier. Fuel efficiency, right, tends to go down. A look at the residual plot shows a problem, right? Maybe it's kind of a pattern there. I don't know. Like Ray, if you're trying to look to see, we can re-express fuel efficiency as gallons per 100 miles, right, and eliminate the bend in that scatter plot. The point is, if we do it this way, we can re-express fuel efficiency as gallons per 100 miles. All right, so gallons per 100 miles. And now it doesn't look like there's so much of a bend, right? A look at the residual plot for the new model seems more reasonable, like there isn't as much of a pattern. I mean, it still might kind of do that, but there isn't as much of a pattern. And goals for re-expression here. Goal 1, make the distribution of a variable as seen in a histogram, for example, more symmetric. Right? If we can make the distribution more symmetric, it'll be helpful. So taking a look at that, if there's a way for us, this is the number, our associations, if I log it, and now I look at my histogram, it looks more symmetric. So you're trying to do that if you can. Is there a way for you to make it, the distribution, seem more symmetric? It's not completely normal, it's just more symmetric. It's a big help. Make the spread of several groups, as seen in side-by-side box plots, more alike, even if their center's distribution it differs a little. Right, so make the spread of several groups, as seen in my side-by-side box plots, more alike, even if their centers differ a little bit. So, trying to make things look more similar, right? There's the original, right? The spreads for the most part. Okay, trying to keep everything pretty close to the same, as close as you can. I mean, those were all over the place, and now look at them. Make the form of a scatter plot more nearly linear. So as you're looking at this, right, that's assets, that's log of the sales. And it's kind of bending, right? All right, there's log of the assets as well. I logged both of them, and now it's appearing more linear. I logged one, there was a bend to it. Now I logged both, X and Y, and it appears to be more linear. You're trying to make the data fit and make more linear. So make the scatter in the scatter plot spread out evenly rather than thickening at the ends. This can be seen in two scatter plots we just saw, right? Right there, really clustered. I logged both of them. It kind of spread it out a little bit. All right. There is a family of simple re-expressions that move data toward our goals in a consistent way. This collection of re-expression is called the ladder of powers. The ladder of powers orders the effects that the re-expressions have on data. So for example, power 2, all right, name, square the data values. Try this with unimodal distributions that are skewed to the left. So if you're seeing data that's skewed to the left, right, you may want to try to do that power, okay? raw data. Data with positive and negative values and no bounds are less likely to benefit from any kind of re-expression, so you're fine with it as is. But square rooted data, counts often benefit from a square root when you're talking about the counts of stuff. This will use logarithms here, right? So when there's not using a power at all, measurements that cannot be negative often benefit from a log. So if there's any kind of measurement that can't be negative, going to use logs. Reciprocal square roots, an uncommon re-expression but sometimes useful, and the reciprocal of the data, a ratio of two quantities, often benefits from those. So if you're looking at a ratio between two different quantities, that's why they're saying something like maybe miles per hour, oftentimes benefits from that. Your logs and your reciprocals, again, you might want to go to first and foremost. This is just a cheat sheet of how I might be able to see which one do I want to do first. Okay. Attack of the logarithms. So when none of the data values is 0 or negative, logarithms can be a useful ally in the search for a model. So that's when you're going to want to do logs. If you're looking at your data, because you can't take a log of a 0 and you can't take a log of a negative. Try taking the log of both the x and y variables. Then re-express the data using some combination of x or log x versus y or log y. So the point is, log them both. See what happens. Log one, log the other. See what happens. So, exponentials, right? If you do this, this model is the 0 power in the ladder approach, useful for values that grow by percentage increases. This one right here, right, is a wide range of x values, or a scatter plot descending rapidly at the left but leveling off towards the right, may benefit from trying this model, all right, and log them both. This is the Goldilocks model. When one of the ladder powers is too big and the next is too small, this one may be the best to do. So this is just showing you when to use some of these. Honestly, sometimes I just mess around. If I can't really judge, I try them both. I try one, I try the other. Just log your x or log your y values. But again, it only works if you don't have 0 or a negative. So multiple benefits. When often you choose to re-express for one reason and then discover that it has helped other aspects of the analysis, it's good. And for example, a re-expression that makes a histogram more symmetric might also straighten a scatter plot or stabilize variance. So you can have other benefits. So why not just use a curve? If there's a curve in the scatter plot, why not just fit a curve to the data, right? So look, there's a curve. Why don't I just do that? I'm noticing a curve in my data. Why don't I just use the curve? The mathematics and calculations for curves of best fit are considerably more difficult than lines of best fit. That's the point. You can do that if we're starting using calculus and stat, but for the time being we aren't. Besides, straight lines are just easier to understand. So you know how to think about the slope and the y-intercept of a graph, so why don't we stick to making it a straight line? So we're trying to make it a straight line. So what can go wrong? Don't expect your model to be perfect ever, and don't stray too far from the ladder. Don't choose a model based on that alone. Okay, you want to look at the regression first to see if you can notice whether to do something or not. So when you're looking at this stuff, you could square root it. Notice, all right, if I square root it, look, I see a pattern there. That's not going to necessarily be good enough just by looking at it. Okay, beware multiple modes. Re-expression cannot pull separate modes together. Watch out for scatter plots that turn around. All right, re-expression can straighten, may bend relationships, but not those that go up then down or down then up. So the point is, take a look at this. All right, re-expression can straighten many bends, but not those that keep doing multiple things. All right, it can help, but it's not going to help a ton. Okay. Watch out for negative data values. It's impossible to re-express negative values by any power that is not a whole number on the ladder of powers, or to re-express values that are 0 or negative powers. Can't use logs, right? We went over that. So watch for data far from 1. Data values that are all very far from 1 may not be much affected by re-expression unless the range is very large. All right. If all the data values are large, consider subtraction and constant to bring them back near 1. So what have we learned? When the conditions for regression are not met, a simple re-expression of the data may be helpful. A re-expression may make the distribution of a variable more symmetric, which is very helpful. The spread across different groups more similar as well, which will also be helpful. Form a scatter plot that is straighter, and remember, if we can keep things in terms of straight lines, it's just easier for us. We know y-intercepts, we know slopes, we can decipher the data and predict it much easier. Scatter on the line in a scatter plot is just more consistent if you can somehow make it fit. Taking logs is often a very good and simple starting point with these. It's where most people will start, to log the x's and log the y's, see how straight the data is, and then judge from there. You can even, a cheat that I've done in the past is you log them. When you log the x, you see what the data was for your r squared, and then you log the y, you see where that was. You can log the x and y. I mean, it's more time intensive to do it, but you can see which r squared is the best. To search further, the ladder of powers or the log-log approach can also help us find a good expression. I normally log them both last. I normally start with the x and then start with the y to see what's happening. And our models won't be perfect, but re-expression can lead us to something that is more useful and more meaningful. All right, that was just helping us with re-expression of our data, and we went over a lot of this too when we did the overview as well, and I'll give you some practice problems here on re-expressing the data when we come back, if you want to look at some of those, and then that's it for the chapter. I will give you an overview, a kind of review of everything all at once, and we'll end with that, and then you'll be ready for your test.